All right, let's get started here. This is going to be a collaboration between John Saunders at NYC CNC and myself, and there's a good chance that you're coming here after watching his video, and hopefully that's the case. If not, go to his channel, watch his copy of this first. A quick rundown of the premise is that this is his part. John programmed what I have in front of me here, and what I'm going to do is just run through it, make whatever changes I would make to it, and then he's going to run them, I think on the same machine, hopefully on the same machine, and see how the two parts compare to each other. I'm not targeting cycle time improvements here because it just doesn't make sense for me to try and push the limits of his machine that I'm totally not familiar with. So I think we're just really looking at final part quality, and those are going to be the things that I'm going to target. But I am going to make some just sort of general improvements to that I think probably would have an efficiency improvement along the way, and it's basically just going to be hopefully eliminating some tools, eliminating some operations. So let's run through and see what he's got first here. So to start off, he's got a face mill or probably a fly cutter that's running across the top surface. I'm going to get rid of that because I think all it's on the final part, all it's going to have done is finished up this very top surface, and I think we can get something that's aesthetically pleasing and probably faster otherwise. So we'll get rid of that one. Next up, he's got a shear hog that's running around and roughing all of this off. I think this is a really great tool, but I think this part has another tool in here that's a little bit better suited for this, and that would just ultimately give you more control over basically everything. This probably is just fine, but I can see that it's not staying consistent on the depths. This part just doesn't have sort of friendly geometry for the shear hog. So we're going to get rid of that one. Next up, he's got a 5/16 end mill that's coming in, finishing the inside of the bore, finishing the outside of the profile, and then finishing this vertical wall. Those are all fine, but there's just no reason to have three, and I think we'll ultimately just get rid of this operation that's finishing this vertical wall, but then we'll pair the ID bore and the OD profile into a single operation. He's got a horizontal toolpath that's coming in here and hitting this flat area, and that's fine, but horizontal's kind of quick and dirty. I think we can just do better and get something that, this is, if you look at it, it's dropping down and then heading towards the inside, sort of pocketing out, then making its way all the way around here to the next one, pocketing out, then doing an outside pass that's totally redundant, and then an inside pass that's also, that one's fine, but it probably won't have a very clean look by the time it's done this in sort of this segmented way. So I think we can just do a little bit better there too. This is he's got this 3/8 end mill with a nice big bull nose radius on it, and it's being used on an adaptive clearing to sort of rest machine this curvy area or this 3D surfaced area, which I think is great. But what we're going to do is we're actually going to use that to do all of our roughing because I think it's a great one. Let's see. Next up, he's got a scallop that he's using to do this lower fillet. I like that one as well. We're going to keep it and also bump it up here, but we're going to modify it and use it to do probably this whole entire section. This is sort of the second half of that. This is probably a duplicate and just is hitting this upper section. We'll get rid of that. We'll use this one to do the whole thing. He's got a drill that's pre-drilling these holes, a boring operation that's boring them out to size, a chamfering operation that's chamfering them. I think all of those are just fine. I'm going to leave them exactly as is. And lastly, we've got a 3D contour that I think the intention is that it's to clean up this fillet radius here. I'm not sure why there's some stuff hitting the flats here, but we're going to just blow this whole thing out and we'll make a copy of this upper scallop to do that. Okay, so let's take a look first and dive into this adaptive. You can see that it has plenty of flute length to just hit the whole depth of this part, and what I want to do is basically use it to bore out the inside of this and then also hit working from the inside out or outside in, from the bottom up basically, and just kind of take care of all of that in sort of one fell swoop. That should give us kind of optimal engagement throughout this whole thing, and also just get us something that is right off the bat really close to net shape and just allow us to go straight into finish. I'm not going to tweak with his speeds and feeds. Those are just fine. We'll assume that he's spot on there. Like I said, he was using this as a rest machining, so I'm just going to sort of set it back to normal defaults. We're going to give it no boundary, and we're going to tell it to rest machine from the original setup stock. Same deal here, he was limiting it to this bottom face. We want to let it go all the way down. We'll actually make a little tweak to that too, I think. Okay, I'm going to reduce the optimal load because I'm not familiar with his machine, and I'm now going to be taking more than what he initially was. I think he's got a maximum roughing step down at 0.2, and I'm going to take it basically all the way up to, well, literally to the full tool flute length. If you're not familiar with what I'm doing here, check out some of the other videos. Basically, you can drive any parameter in here by looking at another parameter, and if you hold shift and mouse over, I think it's the same in Fusion. Yeah, you can see there it shows parameter name, find step down. So that's what I'm driving this with, the parameter name from the tool's flute length. I'm not sure why it doesn't populate automatically in Fusion, but that's okay. So I'm going to let that go down. We'll keep flat area detection on. Keeps that good. And let's just generate it and see what we get here. Like I said, my goal is to work from the outside in, except that maybe we want it to finish the inside first, which would be okay. And let's take a look. I mean, we got something pretty close. We're getting a whole lot of retracts here, and we can reduce those. It is starting from the outside, working its way in, and then at some point in there, it's jumping into the center. So something I'm noticing is that because we have vertical stock to leave and we're driving it to the bottom, the tool's actually not driving all the way down. What we want to do is actually have it drive a little bit less, or drive a little bit deeper, and we'll correct that. So let's pop in here on the model bottom. We actually want this to go deeper by the vertical stock to leave. And again, like that will update, and it will pull this parameter or this integer out and fill that in. So now we'll be going down deeper by the amount that we're leaving, and we'll clean up exactly at 0. Okay, so then what we're going to do is we'll reduce, or we're going to switch to minimum retraction, which that way if there are any retractions, they'll be sort of as small as possible. We're going to increase our maximum stay down distance, just allow it to find a solution with a keep down move that's further if one's available. And then we're going to increase the stay down level, which is kind of it's how much effort it puts into finding a linking move or a path that doesn't involve a retract. This sort of comes directly at the cost of increased calculation time, and in some cases it's not runtime friendly either. It really just depends on the machine. But in this case, I just want to sort of show it and get a nice clean toolpath that hopefully, with very few retracts or hopefully no retracts, works its way in. So we did get at least one retract here. Let's take a look and let's simulate this. So we're working from the outside in. You can see we're now actually hitting the depth of the bottom of the part. So it did do the outside first, retract to hit the inside, and then it's going to make its way back out, which is kind of funny that it did it that way. I might change that to drive. I probably could do an entry position and tell it to start in the very center and then work from the outside in. But we might give it a shot if we have anything else that we want to correct. Otherwise, I probably wouldn't dive into the operation and regenerate just to fix that, or just to change that. So otherwise, this is looking pretty good. I'm just going to speed it up a little bit. Okay, so I am seeing one other thing here, which is that sort of the goal of roughing or roughing with these micro steps is that we want to get really close to the final size, and we're doing pretty good here, but because of how shallow this area is, it's leaving a lot of stock here. You can see we're really nice and consistent on the amount of stock, and then it just gradually increases a lot. And we want to get rid of that. So I think that one's worth diving in here to do. What we can do is we'll just enable this machine shallow areas option, which is basically just going to generate more minimum steps in those shallow areas. And while we're at it, let's jump in here and we'll see if this works. We'll try and grab, say, this inside, and we'll see if that works for getting it to do the inside first. This one's, the entry points are kind of a suggestion, so they don't always they're not always going to function the way that you want. But yeah, it looks like we did do pretty good here. Kind of funny, it's still diving into the center to do these sections first. Oh, you know what? I bet there's one other thing we can do here. There's an option for order by area, yeah, and that wasn't checked. On mine, I think I have that basically just checked by default, which should have told it to, we're in this area, we've removed this material, let's go up and take care of this chamfer at the same time. And I bet this gets rid of even some more of those retracts. Yeah, so now you can see we are down to one true retract move for this whole thing. We've done the inside, comes up, hits these chamfers, then starts its way from the out. We did get one additional one, and I'm not sure where that one came from, but actually a couple more here. But either way, it's still doing a pretty good job, and I'll take it. So let's jump into this scallop. Let's take a look at what I don't like about the scallop to start with. For one, this one's not super bad. You can see there's a little bit of imperfect stuff going on here. Mostly it's just really that these passes are collapsing towards the center, and they're going to cause a reduced scallop right in the center of this. Basically the passes are collapsing, and where they collapse, the passes wind up not spaced properly. So if possible, we want to get rid of that. The other thing is just starting from the top and working its way down. We want it to work from the bottom and work its way up. And then we just also want to take care of all three of these faces all at the same time versus sort of one at a time and having three disjointed paths. We want just one clean bottom up climb cut path. So let's see if we can get that. First off, we don't want to use the silhouette. We want to drive this with a selection. We'll grab that and that. That's fine. Let's give it a 1/2 inch of additional offset. And that's just going to get us past the center and hopefully push that that section where we had the collapse of toolpath towards the middle and out of our actual passes, or out of our section where it's contacting. So then we need to enable some touch surfaces because I shut all of these off. I'm going to use an alternate. Basically these would sort of override what's generating our passes, or what our offsets come from. They would come from the effective boundary after all of these sort of layer on. We just want to use the actual boundary to generate our passes because this is a nice perfect clean circle. Then we're going to use touch surfaces to control where it trims those off at. So this will basically trim anything that's not anywhere where the tool's not contacting one of those three surfaces will get trimmed off. Okay, so and I'm guessing that there's probably some height containment going on here because there is, and that's just from me using his operation and sort of changing it. The settings worked for his. I bet this will get us something closer. Yep. Okay. So I was assuming this would happen. We got pretty good on where our collapse landed because I think it's past where we need. Because I'm using touch surfaces, and like I said, as long as the tool is in contact with one of those surfaces, it'll keep generating passes. That includes the flat of the tool, not just the radius portion. And so all of these passes are sort of totally redundant, or at least they're not efficient. So we want to get rid of a bunch of those ones. I think what I'm going to do is we'll use a slope containment. We'll just tell it to stay off of horizontal surfaces by a very small margin, by basically an imperceptible margin, and that should trim out anything once the tool rolls over and onto the bottom. So you can see that's much cleaner. It's hitting the whole entire thing now. What I am noticing is that it's starting at the top and working its way down, and it also looks like, if you're following these, that it's working its way, and we can simulate to validate it. It's working in a conventional cut, and we really want a climb cut here. One of the things about scallop is that it really doesn't know where the material is at, or what side of the tool the material is on. You could imagine if this was a U shape, then potentially, well, we couldn't really do the type of toolpath that we just did, where it's all offset in one direction, and not swap from a climb cut to a conventional cut without changing the direction that we're going in the middle. So what we want to do is we want to work from the bottom up, and we want to work in a climb cut as well. So now your inclination might be to jump in here and you see up/down milling, and you're like, oh well, yeah, I want to mill up, right? So I'm going to change this from don't care to up milling, but that's really not the option that we're looking for. What this is intended for is, if you can imagine, we have a toolpath that's working its way and along here, and then at this point it starts coming down, right? What this option would do is it would allow it to move, say you selected up milling only. It would allow it to proceed through here, and that's good, and also through this section because it's not, there's no decline to it. But at the point when the tool started to decline, it would then retract, move to the other side of the tool path, or at least to the point where the decline has stopped, and then it would work its way up. So that's not what we want. Our tool path here is really basically entirely shallow. The only thing that's controlling it is whether the tool path is working from the inside of the boundary towards the outside or the outside towards the inside. Currently it's working from the inside of the boundary towards the outside, which happens to cause it to work down the hill. We just want to change it to work from the outside towards the inside. And then we'll set this to one way. I'm guessing this is still going to be wrong, but we'll calculate it and check. Most likely it needs to go the other way. Both ways, typically the direction that it's going is going to be the one-way direction. So now you can see that it's starting at the bottom and working its way up, but you can also see that it is still in a conventional cut. So we'll just come in here and we'll swap that the direction to be the other way. We'll see what we get. I got to apologize. I'm coming off of a little bit of a cold, so if I'm doing any sniveling or excessive swallowing or any of that stuff, forgive me. So now you can see we're still working from the bottom up, but we're doing it in a climb cut, so that's perfect. So we got rid of our operation that was doing this fillet, but what I think we can do is basically just duplicate this. We'll just use this duplicate since it has really similar settings and it's doing something really similar. We'll grab it and we'll use it to finish this fillet. This is an annoyance or a pet peeve of mine in Fusion. I don't use the cam that often, but I'm selecting surfaces, so why does it keep trying to grab the whole body? I don't think I've ever managed to select keep surfaces in here without it picking the body. That was maybe the first successful time I've ever done that. Let's see what we get here though. I'm guessing that we have some configuration to do here. Yep, again we need to go from the model bottom. Everything else should be good there. Alright, so that's looking pretty good. Similar to how before we were touching this horizontal surface and we needed to trim stuff off and we added that slope. Now I can tell that we're hitting this vertical area, and we're going to come in with a different tool and finish that up. So we really just want to trim this. We can just do the exact same thing, so this isn't not much of a teaching moment here. We can just tell it to also stay off of verticals by 0.01 degrees, and that should imperceptibly trim it up as well. Yep, that did a good job. And you can see we're still dropping in, working from the bottom up. We're in a climb cut, still working good. All right, so that's looking pretty good. This guy's looking pretty good. This guy's looking pretty good. This one's looking pretty good. What do we got here? Okay, so I got rid of the toolpath that was doing the outside. We'll just go ahead and add an additional pass in here to take care of the outside. What else did I delete? Oh, I deleted the toolpath that was finishing this surface and this surface. So what we'll do is we'll come in here. We're going to use a 2D contour. Both of these are going to be pretty similar. What we're going to do is make use of 2D contour with stock defined. And in one case, I think we'll use roughing passes as well, not on this one. So we want this to go this direction. We're going to use stock contours, and we're going to choose this because that's the area that we want to machine. What this is going to do is, in this case, it's just going to give us a nice plunge that's off of the material, or that's guaranteed to be off of the material, and works its way in gradually and then comes around. And the next one, it'll actually do some trimming of the paths for us as well. So let's just go ahead and generate this and take a look at it. So I chose, basically it's driving the outside edge or the outside edge of the diameter up to this line that I chose. If we take a look, that's actually not going to work that great because this tool has a great big corner radius on it, which is going to be awesome for our floor finish, but Right now it's not even finishing that floor. So what we want to do is drive this over by at least the radius of the tool, if not plus a little bit. So we'll jump back in here. I'm just going to use stock to leave to do this. We could make an offset contour or something like that, but this is just going to be much easier. So again, we're going to pull, actually, let's go ahead and do this as an expression. We'll say minus the tool corner radius, which should be 60 thousandths, and then we're going to add, let's say 20 thousandths, 0.02 inches into that. And so you can see that gets us minus 0.08. We do not want the axial stock to leave, so we're going to get rid of that. Let's take a look at what that gets us. So now let's jump in and do the same simulation. You can see now we are hitting it with the flat section of the tool across the entire surface, and we're actually going past the radius by some amount, which is perfect. Let's go ahead and move this guy up here. And then we're going to duplicate this, and since we're going to use the same tool and a lot of the same technique to finish this area, we'll just base this one off of that. Let's go ahead and blow out the contour. Grab this as our contour. Let's grab this outer edge of the profile as our stock contour. And so then we're going to basically just use the same operation as before, but you'll see that, well, this will have two problems at least. Right now, if we drive this, it's not going to get all this area out here, and this is going to be left just roughed, right? So we need to generate some offset passes. Let's go ahead and jump back into this. I don't know how clear this will be, but because of that extra 0.02, it also would be kind of blowing out this section here and machining the flat too far. So in this case, we would just want to come in here. Let's fix that one first, and we'll say edit the expression, and we'll get rid of that additional 0.02 inches. Now it resets to the minus 0.06. And lastly, what we're going to do is enable roughing passes. We're going to reduce this down a little bit just because we want to ensure that we don't leave any, well, actually, the default expression should be good. But what we do want to do is increase this to be basically the same amount. We'll do 0.2. That's just because we're not actually finishing a sidewall with the cutter, so we might as well just do this in as few passes as we can. So when you enable roughing passes, what does that do? Basically what it does is it takes and generates offset passes from here by this amount. And if we don't have, let's go ahead and add some of these in here. Here we'll do 10. If we don't define our stock contours, what you'll see is that it just continues offsetting those by the number that we specified. I said to do 10 passes, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 passes, right? And so that's fine. What we want in here with the method that I'm going to use is we just want enough to get it out past the stock contours. You could put in some gigantic number here, but it does, eventually it starts adding up. Offsetting a contour is actually a somewhat computationally heavy operation. So if you put in 1,000 there, you'd see this operation would take some time. But so what we're going to do is we're going to use the stock, by defining the stock contour, we can trim those passes up. And you'll see that even though we're still generating passes that go way out to here, it's going to trim them based on when the tool is in contact with that stock. And so now we get a nice clean finish of that. It's all following, it's all working from the outside in. It's much better, much better. Let's see, I don't think we have anything else to do here. I think we're looking pretty good. Let's do a simulate here as the final. We'll turn off some stuff and make this not transparent, and I'm not sure where this is starting from. There we go. Go ahead and speed it up. You'll see that we're carving out that bore. We hit that chamfer, working our way from the outside in. Go ahead and skip to the end of that one because we already did it. As you see, we went in and we finished that upper surface. Now this is our second 2D contour. Just went in and perfectly finished that up. You can see a little graphics glitch there going on. I'm not sure what the deal is. I think that Fusion doesn't do a good job when it has two tools that machine into the same surface. That's all right. We've got our nice scallop toolpath that's working its way from the bottom up. If you were a mold maker, you might have seen that in that spot right there, it was heading up, and then at some point where the tool was taking nice real light passes, at some point it started cutting that sidewall, and that might be an instance where we would want to go in and carve our way that vertical wall first so that there's zero change in tool deflection as we head up that surface. But I think we'll be all right here. We're not looking for that level of perfection. Got that fillet going. All right, and I'll take it. I think that all looks pretty good. Thanks for watching. Hopefully this worked out pretty good. If people like this, I think it would be a cool idea to keep doing these and maybe even at some point do them live, where I get somebody submits a part that's similar to this and just wants to see what I would do differently or how I could tune it up. But I think this is good for now. Let's see, follow me here if you're not already. Click the subscribe button or whatever. Also, if you're not following me on Instagram, you should do that. Other than that, take it easy.